This is a citrus fruit, a lime, and it's not for gin and tonic. Today, we're going to prove that ancient civilizations had electricity. With nothing more than a couple of lemons, 2 different metals, and a few wires, you can generate a measurable electric current. The acid in the fruit acts as an electrolyte, a liquid that allows charge to flow between the metals. The point is simple: you don't need advanced technology to produce electricity. And those are materials that have been available to humans for thousands of years. And here's the question. A man working in the Baghdad Museum in Iraq picked up a small clay jar, about the size of a coffee mug. Inside was a copper tube, an iron rod, and a seal made of black bitumen, 2 different metals, and a space for liquid. The same basic principles as our citrus fruit. When someone made a replica and added vinegar, it produced electricity 2,000 years before the inventor of the electric battery, the Italian Alessandro Volta, was born, and 2,000 years before Thomas Edison created a working battery. So if anyone can produce electricity with even just citrus fruits, could the ancients have done it with a clay jar 2 millennia ago? And if they did, then what were they using it for? 1066, 1769, 1939. History is built on facts, dates, and the people who shaped our present. But what if we have got it wrong? What if Churchill had been killed before the Second World War? Were the pyramids really built by the pharaohs? And did Shakespeare actually exist? Join us on History Facts as we delve into the mysteries of history together and ask that question: what if we got it wrong? The mysterious jar was found at Kajut Rabu, a village just a few miles from Ctesiphon. And Ctesiphon is one of the greatest cities the ancient world ever produced. For nearly 8 centuries, Ctesiphon served as the capital of 2 successive empires. First, the Parthians, who ruled from around 247 BC to 224 AD, and built an empire stretching from the Euphrates to the very borders of India. Then the Sassanids, who overthrew the Parthians and ruled until the Arab conquest in 651 AD. At its height, Ctesiphon was probably the largest city in the world. Some estimates put its population at over 500,000. It sat at the crossroads of the legendary Silk Road. Roman silver flowed in from the west. Indian spices and Chinese silk arrived from the east. It was a city of scholars, physicians, astrologers, and craftsmen. The Tat Khazra, the great arch of Ctesiphon, still stands today. It is the largest single-span vault of unreinforced brickwork ever built, over 37 meters high, 1,500 years old. And it was just the entrance hall to the royal palace. These were not primitive people toiling away in the grit and the grime of a primitive age. They were sophisticated, cosmopolitan, and technically brilliant. They produced excellent metalwork, complex irrigation systems, and some of the finest glassware in the ancient world. And the Sassanid Empire was also a place of extraordinary intellectual activity. The Academy of Gondisapur became the greatest center of learning in the ancient world. Greek philosophers, Syriac-speaking scholars, Indian mathematicians, and Persian physicians all working side by side, translating texts on medicine, astronomy, and what we now call chemistry. So, when a small clay jar with unexpected metal components turns up in a grave near Ctesiphon, we should expect the unexpected. Now, the official history of electricity begins in the 18th century with Benjamin Franklin and his kite, with Volta and his pile of metal discs. But that's not the whole picture. Humans have been encountering electrical phenomena for thousands of years. They just didn't have the framework to understand what they were seeing. Around 600 BC, the Greek philosopher Thales of Miletus is said to have noticed something curious. If you rub amber with cloth, it begins to attract small objects, feathers, dust, strands of hair. We now call this static electricity. And the modern word electricity itself comes directly from the Greek word for amber, electron. But Thales didn't understand what he was observing. According to Aristotle, writing 2 centuries later, Thales believed the amber contained a kind of soul, that it was alive in some way. He saw the effect, but he had no theory to explain it. Far more dramatic was the ancient world's experience with electric fish. The Mediterranean torpedo ray can deliver shocks of up to 200 volts, powerful enough to numb a human arm. Ancient physicians knew this perfectly well. In the 1st century AD, the Roman physician Scribonius Largus prescribed a specific treatment. Place a live torpedo ray on your head for headaches, or stand on one for gout. Targeted electrotherapy 2,000 years before anyone understood what electricity really was. The Egyptians knew the Nile electric catfish, which appears in art as far back as the Nemea Palette, around 3100 BC. Ancient writers across the Mediterranean described these fish with a mixture of fascination and fear. But here's the crucial point. From Thales in 600 BC to William Gilbert coining the Latin word electricus in 1600, that's 2200 years. Another 2 centuries to Volta's battery. Another 31 years to Faraday's electromagnetic induction, another 48 to Edison's practical light bulb. Each step required thousands of documented experiments building on previous work. Every stage of the journey has been recorded. Every breakthrough has a paper trail. We have shown that electricity can be produced easily with the most rudimentary tools. Ancient people knew about electricity, but where is the evidence they actually harnessed it? Well, we actually have at least 3 compelling examples from history. In 1936, during railway construction near Baghdad, an ancient site was uncovered at Kajut Rabu. The finds were brought to Baghdad Museum, where they later came to the attention of an Austrian named William Koenig, who held the post of assistant director of the museum's laboratory, was cataloguing the hall when one object stopped him cold. A terracotta jar, roughly 14 centimeters tall, 8 wide. Inside, a rolled copper cylinder, about 9 centimeters long, its bottom sealed with copper and asphalt. And sitting inside that cylinder, a completely corroded iron rod, about 8 centimeters long, held in place by an asphalt plug at the top. Koenig saw it immediately. 2 dissimilar metals, a potential space for an electrolyte. It was the basic architecture of a galvanic cell. In other words, a battery. He published his hypothesis, and then when people built replicas, it worked. The General Electric's high voltage laboratory poured in copper sulfate solution and measured roughly half a volt. Students at Smith College in Massachusetts used vinegar and got just over 1 volt. And more recently, the Mythbusters built 10 replicas with lemon juice, wired them in series, and generated over 4 volts, enough to visibly electrocute a small token with zinc. Mesopotamians of this era produced gold-plated silver with astonishingly thin, even coatings, the kind of finish that could only be created by electroplating. A working battery, nearly 2,000 years before Volta. And it wasn't unique. A number of similar vessels had been found at Seleucia and Ctesiphon. This wasn't just a one-off. So, if ancient Mesopotamians had batteries, then what were they powering? 1,500 kilometers to the west, carved into the walls of a hidden underground crypt beneath the Temple of Hathor at Dendera in Egypt, there's a relief that has been driving people mad since the 1960s. An elongated bulb-shaped oval. Inside, something that looks exactly like a filament, and at the base what appears to be a socket. Running from the socket to the box-like structure, something resembling a cable, and the whole thing is supported by a ridged column. In 1982, 2 Austrian authors showed these carvings to an electrical engineer named Walter Garn. He built a sealed glass tube filled with low-pressure gas, shaped to match the carving. And when he ran a current through it, it lit up. They demonstrated a working lamp at the Frankfurt Book Fair that very year that looked almost identical to the thing on the temple wall. Clearly this is a light bulb powered by batteries. It is the only practical explanation for how ancient Egyptians illuminated their deep temples, pyramids and tombs without leaving soot on the ceilings. Now hold that thought. You've got batteries in Baghdad and bulbs in Egypt, and now travel east to find the most sacred object in history. The Book of Exodus gives precise specifications for the Ark of the Covenant. Roughly 113 by 68 by 68 centimeters, overlaid with pure gold inside and out. A solid gold lid topped with 2 golden cherubim wings outstretched, facing each other. Two conductive layers of gold separated by an insulating layer of wood. If you're an electrical engineer, you're already seeing it. That is a capacitor, a device that stores electrical charge. The same basic design as a Leyden jar, which, when it was invented in 1745, was so revolutionary that people called it bottled lightning. The first time in history that humans could capture an electrical charge and release it at will. Except that the arc was described 2,500 years earlier. One of the founders of electrical science, George William Lichtenberg, noticed a resemblance back in the 18th century, and an engineering dean at the Lotus Institute in Chicago calculated in 1933 that the arc could theoretically store up to 10,000 volts, bottled lightning in the Holy of Holies. A battery in Baghdad, light bulbs in Egypt, and a capacitor in ancient texts, 3 artifacts. 3 different ancient civilizations. And when you add the documented evidence that ancient peoples generally encountered electrical phenomena, from the amber of Thales, the shocks of the torpedo ray, the ectotherapy of our friend Scribonius, you get a narrative that is starkly different to what we've been told. Ancient peoples noticed electricity in nature. Some of them, the clever ones, the priests, the craftsmen, figured out how to harness it. They built crude devices. They guarded the knowledge. And when their civilizations fell, their secrets were lost. It has been told in dozens of documentaries, hundreds of YouTube videos, and thousands of books that have sold millions of copies. The ancients had electricity. Case closed. Wait. Did they? Let's go back to the Baghdad Battery. The first problem is the seal. In 1989, a German chemist built careful replicas and discovered something devastating. When you seal the copper cylinder with asphalt, exactly as the real artifacts were sealed, electricity production effectively stops. The asphalt insulates the two metals from any electrolyte. For the jar to even function as a battery, you'd have to leave it unsealed. But the actual artifacts were sealed shut. The second problem is the iron rod. The German chemist also saw that the shape was completely wrong for an electrode. If it had been used to conduct electricity over time, you'd expect even corrosion along its length. Instead, the wear pattern is consistent with a stopper, something designed to plug a hole. And remember those gold-plated Mesopotamian objects we were talking about? Well, the British Museum analysed them. They weren't electroplated at all. They were fire-gilded using mercury amalgam, heating a paste of mercury and gold onto the surface, then evaporating the mercury to leave behind a pure gold layer. Think about what that means. Ancient Mesopotamians were handling one of the most toxic substances on Earth, mixing it with gold, applying it at extreme temperatures, and producing finishes so thin, so even, so perfect that modern observers assumed only electricity could explain the results. The proponents of the Baghdad Battery theory aren't giving ancient peoples too much credit, they're giving them too little. They're replacing a genuinely dangerous sophisticated skill with a barely functional clay jar that doesn't even work when you seal it. And the fourth problem? No wires, no connectors, no electrodes, no workshops, no electrolyte residue, not a single piece of electrical infrastructure across decades of excavation at dozens of sites. As a professor of the State University of New York put it, I don't know anybody who thinks it's a real battery. So what about those other examples of ancient tech? Those light bulbs, for example. A German Egyptologist spent years translating every hieroglyph inscription surrounding the Dendera reliefs. And the inscriptions are explicit. They name a god, Harsomtus, Horus, the uniter of the two lands. They describe him emerging from a lotus flower as a serpent aboard the day barge of the sun, his image raised up by the Dejed pillar. Another inscription specifies that the objects are cult statues made of gold and metal, height 4 palms, and gold and all precious stones, height 3 palms. Specific materials, specific dimensions. And they aren't engineering schematics, they're inventory descriptions of religious objects stored in the crypt. Every element has parallels across hundreds of Egyptian temples. The lotus was a supreme symbol of creation and rebirth. Serpents represented solar deities. The Dejed pillar meant stability and was the backbone of Osiris. This is the core visual language of Egyptian religion. And that no suit argument, walk into the hall at Dendera itself and look up. The ceiling is visibly caked with centuries of accumulated soot. Egyptologists have documented oil lamps, linen wicks, and even administrative receipts for lamp fuel in the Valley of the Kings. They used castor oil lamps with salt additives that burned relatively cleanly. They reflected sunlight with polished metal mirrors. And yes, they cleaned the ceilings. The Dendera temple was built in the Thermatic period by Greek-speaking rulers. If they had electrical lighting, why would they not use it in, let's say, Alexandria or Athens or ancient Rome? Instead, it appears, according to the theory, only in the basement crypt of a provincial temple, depicted once with no physical remains. And now, what about the Ark of the Covenant? The Ark is easiest to demolish as an electrical device, because unlike the others, you can just do the maths. Remember, our theory is that the Ark is a capacitor, just like a Leyden jar meant to store an electrical charge. Two layers of gold acting as conductors separated by wood acting as an insulator. It's true that this structurally is how a capacitor actually works. But how much charge could the Ark actually hold? Using the standard formula for parallel plate capacitor, the Ark's estimated capacitance works out to roughly half a microfarad to 2 microfarads. At theoretically 10,000 volts, that gives you about 50 joules of stored energy. Now 50 joules is roughly about the charge you get when a camera flashes. It is enough to give you a nasty shock, but it's not enough to power a light bulb for more than a fraction of a second, and it's a tiny fraction of the energy in a single bolt of lightning. But even 50 joules is fantasy, because you need a way to actually charge the thing, and there isn't one. Engineer David Awad worked through every proposed charging mechanism in 2024. Static electricity from the atmosphere? Well, in fair weather, the voltage gradient is only about 100 to 150 volts per meter. Far too weak. Friction from the priests carrying it? Well, that energy would dissipate straight through their bodies to the ground. The Earth's own magnetic field? Well, Awad calculated it would take roughly 10,000 years to build up even a trivial charge, and that's assuming zero energy losses in the desert. And here's the final problem. Wood is a poor insulator at the best of times, and its resistance drops dramatically when it gets damp. In the Middle Eastern climate, any charge that somehow built up would leak away from the wood far faster than it could accumulate. You can't store lightning in a wooden box any more than you can store water in a paper bag. So as an electrical device, the Ark simply doesn't work. But wait a minute, before we continue, let's not dismiss the Ark that lightly. The biblical accounts describe something genuinely extraordinary: extreme ritual precautions for transport, an exclusion zone around the object, and a pattern of illness and death among those who touched it or came too close. Some researchers have speculated that what the Ark contained may not have been electrical at all, but something else entirely. But that's a question that deserves its own episode. For now, whatever the Ark was, it was not a conductor of electricity. Let's step back from the individual artifacts, and one argument destroys the entire ancient electricity narrative. Where is everything else? When humans actually developed electrical technology, starting in the 18th century, the record explodes. Thousands of batteries, wires, generators, motors, prototypes, patents, textbooks, workshop debris, every stage documented. The ancient world contains none of these intermediate stages, not one. And every one of those theories is modern. Nobody saw light bulbs in the Dendera reliefs until after Edison made the bulb a cultural icon. Nobody called the Baghdad jar a battery until Koenig applied a concept Volta had established a century earlier. The Ark as a capacitor idea is explicitly a 20th century engineering exercise. We see our own technology in ambiguous shapes from the past, because our brains match patterns using the templates we already have. Hero of Alexandria's steam toy becomes a steam engine, Leonardo da Vinci's sketches become helicopters, and Lotus flowers become light bulbs. So, the ancient electricity theories are dead. The Dendera reliefs are mythology. The Ark is bad physics. And the Baghdad Battery is... Actually, wait. Because while those theories can be easily debunked, the Baghdad jar has a problem that debunkers don't like talking about. It resists clear explanation. Here's part of the story that nobody tells. The Baghdad jar wasn't alone. Several identical vessels were found by a German-American team. The same copper cylinders, the same design, the same era. And several of those vessels contained something else. Not electrolyte, not acid residue, not the chemical traces of a galvanic reaction, but the remains of what appeared to be organic material, possibly decomposed papyrus or similar, fragments of what the German-American team described as remnants of written text, possibly scrolls placed inside copper tubes to protect them, sealed with asphalt to preserve them, and buried alongside magical incantation bowls inscribed with protective spells against demons. Think about what could actually have been inside those jars. Not voltage, not electricity, but perhaps something even more important: words, sacred words, protective spells, prayers against evil. Someone, a priest, a scribe, a healer, wrote them down, rolled them up, slid them into copper tubes for safekeeping, and sealed the whole thing with asphalt and placed them in the ground. We don't know what those texts said. The papyrus rotted away centuries ago. Whatever prayers, whatever spells, whatever knowledge was written on those scrolls, it's gone. For almost a century, millions of people have argued about whether this jar could produce half a volt or a full volt, whether it could electroplate a coin. Documentaries, YouTube videos, television shows, books, all debating the same question: was it a battery? And the whole time, the actual contents of these jars, the real artifacts, the ones that are generally inside them, have been completely forgotten. Nobody's asking what the scrolls actually said. Nobody asks what the incantation bowls meant or what ritual tradition those objects belong to. The Baghdad Battery theory didn't just get the answers wrong, it made us forget what the real question is. And that real question, what these jars actually were, what traditions they belong to, and what they tell us about the people, is exactly what we're going to explore in the next episode. Please subscribe to History Hacked. Until next time.